Hey everybody, welcome back here to another quick chemistry video. Today's topic is significant figures and calculations. So earlier in an earlier video, which I'll put a link up here so you can look at it if you like to, we talked about what makes up significant figures, how you count significant figures in a number and a value or a measurement. So if you want to look at that, you could take a look at that video as well. In addition, we talked about really measurements and sort of where those significant figures come from, also in a previous video. So if you want to take a look at that, I'll put a little link here so you could do that. Just really quickly on both of those topics, remember that anytime we take a measurement, whatever it may be, there is always going to be some type of uncertainty in that measurement. So again, here if we're looking at this ruler and we want to measure some type of arrow, we want to always look at the scale and figure out what the large markings mean. And that right there, as the large markings, we have 1 centimeter to 2 centimeters. So that is a difference of 1 centimeter. When we start counting the little markings, which are those between the larger markings, again, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, and a 10. So we got 10 markings between the large markings. That means each of the small markings in this case represents 0.1 of a centimeter. So when we look at this, again, this would be 1.1, 1.2, 1.3, 1.4, 1.5, 1.6, 1.7, 1.8, 1.9. I'll squeeze it in there. And that means that when we look at my arrow where I drew, everybody should agree it is at least at the 1.7 marking, and that's what's considered your certain numbers. Now we can see the arrow is not exactly at the 1.7, not quite at the 1.8. So this is where the estimation, or really the uncertainty in this measurement, comes into play. And again, we want to sort of imagine the spacing between there. You know, is it half? Is it a little bit more than half? So if you feel, for example, I drew a little thick line there. If it's like a little less than half, for example, you would record maybe 4 in this case and centimeters. This number here, the 4 in this example, would be our first uncertain number. And that is typically when you take a measurement, always what you want to record. You want to record all of the certain numbers plus that first uncertain number. And that is what makes up really kind of the significant figures we come across when we see measured values. So in this case, this guy here would have 3 significant figures. The uncertainty sort of in this measurement can be found if you know the smallest marking sort of increments. All you have to do is take the smallest marking divided by 2, and I'll give you kind of like a plus or minus 0.05 centimeters. That's sort of how far the uncertainty is and precision in this particular measurement. And it also will tell you, frankly, how far you can take the reading. So you can see that is 2 decimal places. And that is exactly how far we took the reading to. So again, if you can figure out on your scaling the smallest marking divided by 2, it will essentially tell you how far you should really take that measurement to get it to the proper number of significant figures. So we talked about that in that previous video. We talked about what makes up significant figures, which again, just to run down the rules really quickly, again, all non-zero numbers are significant. We have our zeros, which there are a few different types of zeros. We have leading zeros. They are not significant. So for example, up here, 1, 2, 3, very creative, 3 significant figures since they are all significant. Here, 0.0033. These zeros are not significant. We don't start counting to there. So these 2 guys at the end would be significant. So that is 2 significant figures. We have sort of trapped zeros or captive zeros. And these are significant. And these are zeros, again, between 2 non-zero numbers. So 1003. Start counting here. These are trapped between 2 non-zero numbers. So this guy would have 4 significant figures. Lastly, we have our trailing zeros. And our trailing zeros may may not be significant. And it's really, is there a decimal point pretty much written in that number? So if there is a decimal point written in that number, then those zeros at the end will be significant. So if you have 400 written like that, although we sometimes assume there's a decimal point there, it is not written. That means that the 4 here is technically the only significant figure. Those zeros at the end are not significant because there is no decimal point written. Now, if we took 0.0400, these would not be significant. We would start counting here, and these zeros here at the end would become significant because there is a decimal point in the number, and that would give us 3 significant figures. All right, so now that we kind of reviewed these guys here really quick, let's talk about what we do with calculations. So there's really 2 types of calculations that we do. We multiply and divide, and they're sort of grouped together in terms of how you get your answer when you're doing calculations involving obviously to the right significant figures. When we multiply or divide, the answer we end up with should have the same number of significant figures as, almost like and, as the number with the least number of significant figures, SFs being significant figures obviously here. And that means that if we took, for example, a calculation like 42.3 and we times it by 14, we want to look at the significant figures here in each of the numbers, since we are essentially multiplying. So we're looking at significant figures for our answer. So this guy here has 3 significant figures. This guy here has 2 significant figures. And that means that our answer really should end up with 2 significant figures. So if we pop that into a calculator, I got one around here somewhere. Well, 42.3 action times 14. And on your calculator there, it's going to spit out to you 592, it looks like, 0.2. So in this case, we do want to end up at 2 significant figures. So boom, right there's our second significant figure. We look at the 2, it's less than 5, which means we drop them. Remember, we cannot change the meaning of the number, so 590 here would be correct, as that 0 at the end here is not significant because there's no decimal point written in this number. We could also do scientific notation here if we wanted to. We could go 1 and 2. And here we could go 5.9 times 10 to the 2. Remember that when we write a number in scientific notation, all the numbers before the times 10 part are significant. So in this case, writing it like this gives us 2 significant figures. We have our 2 significant figures here. So either way would be appropriate in this case. Remember that if he did something like this, 5.90 times 10 to the 2, this would be incorrect because this now has 3 significant figures, which is too many. So you would not want to do that. So you got to be careful when you write a number of scientific notation, as we talked about in the previous video. If all the numbers before the times 10 part are always going to be significant. So just keep that in mind. Now, if we divide, for example, some numbers here, 1.32 times 10 to the 4, and we're going to divide it by 23659. And we put that into our calculator. Remember to use your exponent button so everything comes out correctly. So we'll divide that there by 23659. And on your calculator, you're going to get quite a number here, 0.557927. That's sort of what it shows on my calculator. And again, here we want to look at significant figures. So once again, here we're dividing. So that is 3 significant figures there because it's in scientific notation. This guy here, all of them are significant. So that is 5 significant figures. 3 is the lowest, so that is where we want to end up. And again, if we look at this number on our screen, 3 significant figures is right there. We look at the 9 in this particular case. We do need to round up, so that's going to give us 0.558 3.8 as our answer. 3 significant figures in that case. Also, we could do scientific notation, move to decimal place 1 place if you wanted to. 5.58 times 10 to the minus 1. So if you multiply or you divide, we're looking at significant figures. It is always the one with the least number of significant figures is what you're looking for. Now, the other sort of operations that you do is you add and subtract. And when we add and subtract, we're actually looking at something a little bit different. We're not looking at significant figures, but we're actually looking at decimal places. And it is also the smallest number of decimal places is what we're looking for our answer. So if we were going to add some numbers like 12.111 and we're going to add it to 3.22 and add it to say 1.1, we do all that again, go without the calculator here, give it a try. We got a 1, we got a 3, we got a 2, 3, 4, we got a 4, 6, and a 1. Hopefully I did right. Hopefully looks like we did it all right there. So when we're looking at this, again, we're not looking at significant figures here. We are looking at decimal places because we're adding, and we look here, that is 3 decimal places. That is 2 decimal places. That is 1 decimal place. That means my answer actually should end up at 1 decimal place, which is right there. That's going to translate into 16.4. Now, it does have 1 decimal place, but it's also important to keep in mind that in terms of significant figures, it actually has 3 significant figures, which might be very important if you were going to continue on and use that in another calculation. So again, adding or subtracting, we're looking at decimal places. Take a look on one more here, 120.4 minus 3.33. So again, if we pop that into our calculator here, I know what you're thinking. Why not do it by hand? I know. It's all right. I got a calculator. 117.07 happening here. And at this point, what we're looking at is decimal places since we're subtracting. So we got 1 decimal place there. We got 2 decimal places. That means my answer should end up at 1 decimal place here. We're going to round up in this case. Going to give us 117.1. Again, it has 1 decimal place, which it should because we subtracted. But if we were going to use this in another part of the calculation, then obviously here we would have 4 significant figures. So significant figures, decimal places, obviously different. But when you're adding and subtracting, you are looking at decimal places, not significant figures. When you multiply and divide, you are looking at significant figures. One last little bit here about calculations. Obviously, you need to keep track of your significant figures. You obviously, as well, usually do not want to round too much until the very end, but you should keep track of it. So, for example, if we're doing a number of sort of steps along the way, if we had, say, maybe a combination, we take 3.3 times 42.6 divided by 12, for example. So if we're going to do this problem here, and we're going to do a little scientific notation, or not really scientific notation, but significant figures here, and we are going to figure out what we want to do first. Here, what we want to do first is what is in the parentheses is typically what we want to do. So we are multiplying here. So for example, this would have 4 significant figures. This would have 3 significant figures. And then we're going to take that number on top, which technically, if we got the answer here, should have 3 significant figures because, again, that is the proper procedure there for just the top part of it. We would then be taking that number on top, which technically has 3 significant figures, divided by this number on the bottom that has 2 significant figures. That means when we're all said and done, really, that is where we should end up, is 2 significant figures. So let's see how this works. So if you take the top part, we take 333.3 times 42.6. We get some number like this, 14198.58. and we would then be dividing it by 12. Now, we do know at this point that the top should have 3 significant figures, which when we talk about 3 significant figures is actually right about there. Now, at this point, if I was doing this problem personally, I would not round that to the 3 significant figures at this point, because I'm going to be using it to do the next part of the calculation, which is I'm going to divide it by 12. But I should keep track of where I should end up. And sometimes people put a little line like I did there over the 1. You don't have to, but sometimes people will do that. And you really don't want to round to the very end, usually in most calculations that you do in chemistry. You sometimes keep what people refer to as guard digits. Like maybe if you did want to punch it back into your calculator, maybe you would take just the 14,198 or something like that, and then divide it by 12, keep a couple of extra digits that, you might need. Personally, for me, if I was doing this in my calculator like I'm doing it right now, I would take the whole number that's still in my calculator and I would divide it by 12 in this case. And when I divide it by 12 in this case, I will end up with 1183.215. So what I know is I should end up with, excuse me, as we talked about earlier, 3 significant figures up on top, 2 significant figures on the bottom. That means my answer now should come to 2 significant figures. I've come to the end of my calculation. Now I could definitely round to the proper number of significant figures. In this particular case, we are going to have to round up because of that 8 that's next door there to the 1. And that will give us something like 1200. Once again, we do not want to put a decimal point at the end there. Otherwise, it would have 4 significant figures. This will have 2 significant figures the way it's written. We also could do scientific notation 1, 2, and 3. And we could do 1.2 times 10 to the 3 as another alternative answer. So if you're doing multiple steps in a calculation, you do want to keep track of your significant figures through each step. Probably that last step in your calculation is going to determine sort of where you end up in terms of your answer. I, again, would not round along the way until you get to the very end. And that's just a good rule of thumb. Keep some guard digits, keep a couple extra digits, and then kind of clean it up at the end when you're doing it, your calculation, and you get to the final step. All right, so that ends this quick little video about calculations with significant figures. Again, just to summarize, if you're multiplying or dividing, you're looking at significant figures, and you're looking for the number with the least number of significant figures. If you're adding or subtracting, you're looking at decimal places. You're looking at the number with the least number of decimal places, and that's what your answer should have in both of those cases. The reason we look at the least decimal places, the least number of significant figures is, frankly, these are all really kind of based off of measurements. So the one with the least sig figs, the least number of decimal places, is kind of like your worst measurement, and that means that your calculation is only as good as your worst measurement. So that's what we do. Again, a couple other reminders here to finish up. Don't round too much until the very end. Keep track of your significant figures in your calculations, especially if you're going to take that number and go on to more calculations. Try to avoid lots of rounding along the way, but keep track of your significant figures. Once again, I hope this helped, this quick little video on calculations involving significant figures. Again, if you want other topics, let me know there in the comments, and we'll see you next time on the next one. Bye-bye.